Have you ever wondered how a star begins its life in the vast cosmos? Today we're going to embark on a celestial journey, a journey that starts in the most humble of places, a nebula. A nebula, you see, isn't just a stunning, swirling spectacle of color suspended in the silent void of space. It's a cosmic nursery brimming with the raw materials needed to create a star. The nebula's gas and dust, scattered across the universe like a giant cosmic jigsaw puzzle, are drawn together by a force you're all familiar with, gravity. As more and more particles cluster together, our nebula starts to shrink, transforming into a dense, hot core known as a protostar. This is the embryonic stage of a star, a celestial infant, if you will. It's not quite a star yet, but it's getting there. You see, our protostar is insatiable, constantly pulling in more gas and dust from its surroundings. This accumulation of material causes the protostar to grow, but it also causes it to heat up. The temperature at its core rises, and pressure builds. Now this is where things get really exciting. When the core temperature reaches a staggering 10 million degrees, a miraculous cosmic event takes place: nuclear fusion. The intense heat and pressure cause hydrogen atoms to combine, forming helium. This process releases a tremendous amount of energy, causing the protostar to shine brightly. This is the moment we've been waiting for. Our protostar has finally matured into a main sequence star. It's now part of the cosmic tapestry, shining brightly and ready to live out its life as a star. And thus, with a burst of light and energy, a star is born. But remember, this is just the beginning. The life of a star is a fascinating tale of transformation and evolution, a tale that will continue to unravel in the scenes to come. Now that our star is born, what happens during its normal life? Well, our star has entered its prime, a stage known as the main sequence. During this period, the star lives out the longest part of its life, which can last for billions of years. Its days are spent in a delicate dance between two forces. On one hand, you have gravity, constantly pulling everything inward. On the other hand, there's the pressure from the heat and light produced by the star, pushing everything outward. It's a cosmic tug of war, and for now, it's a draw. At the heart of our star, a magical process is taking place. The star's massive gravity creates such intense pressure and heat that hydrogen atoms, the most basic elements in the universe, come together to form helium. This process is known as nuclear fusion. It's like the world's most powerful, most efficient power plant, and it's what gives a star its shine. But our star isn't just a pretty face, it's also an element factory. You see, when hydrogen atoms fuse to create helium, they release an incredible amount of energy. This energy is what powers the star and produces the heat and light we see. But it also creates heavier elements like carbon and oxygen, which are crucial for life as we know it. And so, our star, like a cosmic furnace, burns bright and steady, churning out energy and creating the building blocks of the universe. Day in, day out, for billions of years, it's a ceaseless, tireless process. But even stars, with their almost unimaginable power and longevity, can't keep this up forever. Eventually, the hydrogen fuel in the star's core will run out, and when that happens, our star will face the next phase of its life. But for now, let's appreciate the star in its prime. For billions of years, our star shines brightly, a beacon in the dark cosmos. And in doing so, it not only lights up the night sky, but also fuels life on countless worlds, including our own. But what happens when a star runs out of hydrogen fuel? Well, the star doesn't just flicker out like an old light bulb. It enters a dramatic phase of its life known as the red giant phase. In this phase, the star begins to experience a change of heart, quite literally. The core of the star, which has been busily fusing hydrogen into helium, is now choked up with helium. The core contracts under its own gravity, while the outer layers of the star expand, causing the star to balloon to a size many times larger than its original form. As the star expands, it cools down, and the once brilliantly white star turns a deep fiery red. This is why we call this phase the red giant phase. It's not just a clever name, it's a vivid description of what our star has become. But the life of our star isn't over yet. Oh no, the drama is just beginning. As the core contracts, the temperature rises, and when it reaches a scorching 100 million degrees, a new reaction starts. The helium in the core begins to fuse into carbon and oxygen, the building blocks of life as we know it. This fusion of helium into heavier elements is a crucial part of the life cycle of a star. It's not just a phase, it's the birthplace of the elements. Every atom of carbon in your body, every breath of oxygen you take was once fused in the heart of a star. Isn't that a humbling thought? While the star is busy creating elements, it's also shedding its outer layers into space. The material that the star expels will go on to form new stars and planets, continuing the cycle of stellar birth and death. And so, our star, once a bright point of light, has now become a red giant. But even in this state, it continues to contribute to the universe, creating elements and seeding the cosmos with the raw materials for new stars. Every star must meet its end. But how does this celestial demise occur? Well, it's a tale of unimaginable power and profound beauty. As a star exhausts its nuclear fuel, the balance between the inward pull of gravity and the outward push of pressure from the nuclear reactions is disrupted. Gravity begins to win this cosmic tug-of-war, causing the star to collapse in on itself. But wait, the story doesn't end here. The collapse triggers a shock wave that blasts the outer layers of the star into space. This cataclysmic explosion, my friends, is what we call a supernova. It's a grand spectacle, outshining entire galaxies for a brief moment before fading away. Now, what remains of the star after this spectacular supernova? The fate of the remnants is determined by the original mass of the star. If it was about the same size as our sun, it becomes a white dwarf. This dense stellar corpse shines with a ghostly white light as it cools over billions of years. However, if the star was several times the mass of our sun, it becomes a neutron star. These are the densest objects in the universe, with a teaspoon of neutron star matter weighing as much as a mountain. Imagine that. And for the most massive stars, their fate is the most mysterious and intriguing of all. They collapse under their own gravity to form a black hole, a region of space from which nothing, not even light, can escape. They are the ultimate cosmic enigmas, the final resting place of stars that once shone brightly across the cosmos. So you see, the death of a star is not a quiet fading away. It's a dramatic transformation, a testament to the incredible forces at play in our universe. Whether they end up as white dwarfs, neutron stars, or black holes, each star leaves a lasting legacy long after its light has gone out. In a final dramatic burst of energy, our star ends its life cycle. And what about the possibility of life around these remnants? While the intense radiation and harsh conditions make it unlikely, the universe is full of surprises. Who knows what's waiting to be discovered in the cosmic shadows? Even in death, our star continues to influence the cosmos, a testament to its enduring legacy.